Hi, I'm Jonathan Cast, and this is GlobalScript. Um, so I want to talk about mocks just briefly. Um, Talked last time about what I called mockist unit testing and the idea that if you're writing tests for module A and module A calls code in module B, that you always have to mock all the functions in module B that module A calls so that you're only testing the code in module A. I think that's just a really terrible way of designing software or of designing tests. I think it's a terrible way of designing software. I think it's a terrible way of thinking about what the purpose of a test is. The purpose of a test is not to say, does this code work correctly? The purpose of a test is to say, is this feature or is this bit of behavior that the business needs implemented correctly? And so people say, well, I don't want to have to change the test for module A because I changed the code in module B. But the question is my change in module B going to affect the user visible behavior that I'm testing with this particular test? And if it does, then I want to know about that. I want to know, okay, this feature request is now going to work differently than it was originally specified. And so part of the thing here is, and this is a larger video, so I'll get back to this, but you really want to be careful about using assert equals when you write your tests, especially things like assert deep and things like that. We have a big data structure, and saying, are these two data structures identical? Sometimes that's a good idea. Sometimes that's a really bad idea because you're way over testing. You're testing way more functionality than you really need to test for a particular test. Anyway, that's kind of a digression from what I want to talk about right now. What I want to talk about now is mocks. Obviously, mocks are very common. They're very prominent in the testing system. If I was going to stand here and tell you that, at least in conventional testing systems, you never need mocks, you never want to use a mock, you probably would write me off as a lunatic. So I want to talk about, why do you use mocks? When would you use mocks? Well, so obviously the most common answer is you use a mock when you're calling functions outside the module that you're testing. I think that's a terrible answer. Just going to discard that right off the top. Another answer is you use mocks anytime you're doing any kind of I/O. You want to mock out the I/O system and just test the functionality of your system. So people say things like, well, if you're talking to a database, you should mock the database. And that's in some ways an even worse answer. Because again, you've got the same kind of problems that you do using mocks in a dynamically typed language. SQL is statically typed. But if all you're doing is generating SQL strings and throwing that at a database interface, that's effectively a dynamically typed system. And so your test, you don't want to write a test that says, okay, the SQL that I'm throwing at the system is valid SQL. It's accurate SQL. It's SQL that's going to run, right? Let alone SQL that's going to produce the results I want. The best way to verify that SQL produces the results you want is to run it against an actual database and see what results you get back. So if you've got a module and part of that module's job is to run SQL against a database, you want to actually run that SQL in your tests and make sure you get the right result back. So you want to make sure that you're using a database that's local, a database that's fast, a database that you can database that's not going to interfere with your testing, database that's got just the test data you want in it, all of that. But you really, 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 really want to run your actual SQL inside your tests. And then you've got, I'm doing file I/O. I want to mock out my file I/O. Using temp files for test fixtures or things like that can make a lot of sense. Dumping outputs to temp files makes a lot of sense. But again, the simplest way to test the actual functionality is to go ahead and create the file, and then in your test, open that file and find out what's there. Mocking is at best just going to overcomplicate things. A better use case for mocking is my code is talking to a web server somewhere else, and I don't want to, or I can't have a copy of that web server running all the time that my test can talk to. In that case, stubbing or mocking the web server can start to make more sense. Another test case is my code is supposed to talk to this web server and it's supposed to create a state change in that web server, where detecting the state change in the web server, especially detecting that the code created that state change correctly, spinning up the web server, checking the state, all of that, is more complicated than just saying, okay, did it post to this URL with these parameters? And so this is where mocking really starts to come into its own. But I think, and part of the reason for that is your users ultimately probably don't care that you posted to this URL with these parameters, but you're getting closer to a situation where you can reasonably say the specification that I'm going to adopt for this program is that when I do this, it does this on this URL, does this on this other website. And so you're writing your test to the actual specification of your program now. It's just that the part of the specification of your program is this aspect of its I/O behavior. And even an even better, clearer example of this, you have a subprogram which needs to write some things to standard output, and maybe it needs to read some things from standard inputs. And you need to write tests for it. Basically, your options for doing this are you can run the whole program from like a shell script and use input redirection, I/O redirection, to test what gets written out, what gets read in. Or from inside the language, you can capture the standard input and output streams for that bit of code you're running. Or if you can't do that, you can mock the print and read statements. And you can, again, capture the sequence of input and the sequence of output that's happening. And actually test, is this program going to do what I expect it to do? And so that's where mocking really comes into its own. Having said that, the question now that arises is, okay, global scripts, throwing away everything that is purely historical. We're taking what we know, what we've learned, and we're starting over. How would I test, if I've got a piece of code, and that code needs to read from standard input and write to standard output, how would I test that in a global script? And the answer that I've come up with, the answer that I'm going with, is you've got special assertions that say So like when you're testing an integer, you say, I assert that this integer is this value, or it's greater than or equal to this value, or it's less than or equal to this value. When you're testing a subprogram that does I/O, you say, I assert that if I feed this string as standard input, it produces this string as the standard output. Or something like that. You might have a function that takes an I/O subprogram, runs it, and produces a transcript of, okay, it read these things and it wrote these things. And then you can write your asserts over that transcript like it's a big data structure. Things like that, ideas like that. Sort of getting away from the idea of mocking and towards the idea of, okay, the behavior that we're expressing is part of the value of this program. It's part of the denotation of this program. GlobalScript is purely functional, which means the value of an expression is the meaning that the programmer is trying to get across by that expression, extensionally. So if I have a print statement, the value of the print statement is the idea or the concept, write this to standard out. And then I can write an assert on that value that says this statement writes this to standard out. And so then if I go through all of the things that you can express with a language and write an assert for each of those, then you don't have to set up mocking, you don't have to set up special capturing. One of the real keys to writing good tests is you want your tests to read as much like straight line, this is what should happen, as possible, rather than having to decipher, okay, how am I implementing the test for the functionality that I want? The point of tests, if we could look at code and just see, oh, this code obviously does this, we wouldn't need tests, right? The point of tests is that a test is easier to understand than the code that implements the actual functionality. And so I can look at the tests and say, okay, looking at these tests, obviously, code that does the right thing is going to pass the test. Code that doesn't do the right thing is going to fail the test. And so rather than having complicated mocks and having to understand how the interaction works and how, okay, this value ends up being what's written, centered out, and all of that, just write the code as a sequence of assertions that says what your expected functionality is. Write the test as a sequence of assertions that says what your expected functionality is. And then it's obvious what you're really testing. So anyway, that is my really brief thoughts on mocking. Hopefully I'll be able to come back and start talking about, sort of more coherently, how do we actually do testing in GlobalScript? But for now, I am Jonathan Cass, this is GlobalScript, and I am signing off.